Welcome to the 2021 seasonal employee training. My name is Jamie McQuaid. I'm with Environmental Health and Safety. I recognize most of your names. I've seen you before. You usually have been in the GBM program. Some of you are returning. For you, this is a review. For the rest of you, hopefully most of the information that we're going to talk about in the next several minutes is a review, but if you have questions, feel free to ask. So why do we do this every year? What's the big deal? Why are we always going over safety training? Ultimately, a knowledgeable workforce is a safer workforce. That being said, we want you to understand that if you do get hurt, there are some procedures which you have to follow. Reporting injuries and illnesses is a part of your employment at Princeton. So we're going to talk about how you receive emergency assistance. So if you get hurt or you need emergency assistance, you can dial 911 from a campus phone or 609-258-3333 from a cell phone, or you can contact DPS using the PSAFE channel on a radio if you have a radio. The quickest and probably most efficient way is to call 911. In the past, we told you that you couldn't call 911 from a cell phone. That is no longer an issue. There is a geo net put over the campus community. So anybody dialing 911 from a cell phone on campus will go through DPS. So you can now dial 911 and get response through DPS. When do you report an injury? We want you to report an injury as soon as it happens or immediately after your shift ends is the primary time. How do you report an injury? You report an injury to your supervisor and to employee health. So most of you should know where employee health is. If you do get hurt, it is part of your employment that you're required to report that to employee health as well as your supervisor. So why do you report injuries? We report injuries to keep minor injuries minor and to make sure that if there is an unsafe condition or unsafe piece of equipment, that the next person that uses it does not get hurt by it as well. So keeping minor injuries minor is really important. So when we have a small injury, something like a splinter, it may seem a little silly to report it to employee health, but if it's not removed properly and you get an infection, we have had insignificant injuries such as splinters end up with people in the ICU with staph infection. So it's really important to get the medical care you need if you get hurt. And we do accident investigations, not to assign blame, but to determine the root cause of an incident and to prevent it from happening again. So what is our goal? Our goal obviously is zero preventable injuries, but we need to understand a couple of things when we talk about injuries. There are unsafe acts. These are behaviors, things that we do versus unsafe conditions. If you look at this picture, essentially an unsafe act would be walking up to this grizzly bear and smacking it in the face. An unsafe condition would be the grizzly bear behind the rope with nothing else keeping it away from you. As is anytime you're at Princeton, one of the things we want you to do is stop before you do something, think about what you're doing, think about what the hazards are, and then proceed to do it. There is nothing that you can do or no job that you're doing that is so important that you can't stop, ask a question before proceeding. So if you have any questions, concerns, you think something's unsafe, stop before you do it, talk to your supervisor, call EHS. There's no reason you should proceed with anything that is you consider unsafe or are uncomfortable doing. All right.
One of the things when you see hazards and have hazards in the workplace is making sure that you communicate those hazards. And one of the best ways to do it is with signage and tags. When you see a red, black, and white sign, you can kind of ignore the high voltage because it could be anything on here. You see a red, black, and white danger sign, it indicates immediate hazard to life and health, and it indicates that whatever you're around is the most significant hazard you can have. An orange and black sign indicates a potentially hazardous situation, which if you don't avoid could result in death or serious injury. An orange and black sign would indicate a potential hazard or cautions against unsafe practices or potential damages to equipment. And a green and white, like a safety sign, It's going to give you general safety instructions and locations of safety equipment. You see these sort of things when you're in labs where you have a safety shower or an eye wash or something like that. You'll see these signs indicating where those things are located. Signs have to be clear and concise and match the hazards they're intended to identify. So if you look at the picture on the left here, you can see that there's about 7 or 8 different signs on there that are telling you different things. One is snow, one is water. There's really no clear cut thing which you have to, exactly when you look at it what the problem is. And obviously the sign on the right, severe drought, mandatory water restrictions are in effect. And the sign is actually flooded. Signs should be clear and concise. A couple of other examples. Do it right the first time, plan ahead. You can see in that sign that they didn't really plan that far ahead. Another way to prevent people from hazards and to keep hazards separate from the general populations is to set up a perimeter or a barricade. So barricades can be perimeter of work sites. They can surround unattended areas. There's a street opening if there's electrical hazards. If there's blasting operations, some of the construction sites on campus recently have been doing blasting operations. So you want to make sure that people don't wander into those areas when that's going on. If you're using any type of rotating equipment, probably the best example of this would be a aerial lift or a piece of excavating equipment. If you get between that rotating equipment and a barrier or a wall, and that rotates on that structure, that's essentially, it's not going to stop. It doesn't have a warning. So we want to make sure that people are kept out of those pinch points. And if there's any overhead debris being dropped or something like that, you want to make sure that it's barricaded off from the general public. So a couple examples of barricades that I've seen around campus. The one on the left is an insufficient barricade. If you really look at that closely, you can see that it's an excavation. There's also a confined space inside the excavation. We'll talk about that in a minute. But anybody, including the general public, could walk up to this hole in the dark or something like that and fall in it and get hurt. So that's not an adequate barrier for that excavation and pit. The picture on the right shows an exterior perimeter barricade of a construction site, and you can see just by looking at the picture that just about anybody who wants to go through that can go right through that and get into the construction site and be exposed to all kinds of hazards. So that is not an adequate barrier. Construction sites are dynamic. Hazards can change daily, sometimes several times throughout the day. So if you've ever watched the construction of a building, and I think all of us can see, like across the Res College site, and a couple of months ago, it looked completely different. Actually, a couple of weeks ago, it looked completely different than it does now. And this was Lewis Center for the Arts, the picture here. So these things are changing daily as they come out of the ground. And what happens is that the hazards can also change daily. So you really need to understand that the hazards on a site are dynamic, and the hazards that you're exposed to when around these sites are dynamic. It's important to understand the site requirements before you go onto a construction site. Each construction site has a different set of requirements depending on the GC that's running the site. They may require you to wear hard hats and safety glasses. They may require you to wear vests. Whatever they ask us to do, just because we work at Princeton, we're not exempt from that. We must do whatever the construction manager requires. So they told us we had to wear purple hard hats and certain types of boots. We would have to do that to go onto their site. These sites, basically the way that it works is once the fence is up, it is the general contractor's responsibility. It means it's their liability on the site. If we go on to the site, we are acting as a subcontractor to that general contractor. Again, we have to adhere to whatever their requirements are. So some of the things you may need on a construction site, some required personal protective equipment: hard hats, safety glasses, high-vis clothing with reflective striping when vehicular traffic is present. I will say that most construction sites require high-vis clothing at this point. Protective gloves, hearing protection, possibly full face shields when cutting, grinding, or chipping. So when you're wearing a full face shield, you also have to wear safety glasses. A face shield protects your face from flying debris, but it does not protect your eyes. Chemical splash goggles if you're working with chemicals, respiratory protection if you're properly fit tested and fit with that, fall protection if exposed to height, shirts with sleeves, long work pants, sturdy work shoes or boots. Now, for most construction sites, and one thing I will say is some of the shops allow you to wear shorts, but if you're wearing shorts and allowed to wear shorts and you have to go onto a construction site, you will have to change into long work pants. There's no construction site that allows you to wear shorts. So just make sure you have a change of clothing in your locker. Tools and equipment need to be inspected daily and removed from service if defective. Safety guards, devices, or features must be maintained in full operating condition. So let's take a look at some of these tools here. So the picture on the upper right is a grinder. If you look at that, that's not what it should look like when you go to use it. Oh, we're going to go to the bottom left first. My bad. So this is a table saw. This is a table saw with where the guard has been removed. We only are allowed to use table saws with the saw stop thing. So with the way that the saw stop works, I don't know if anybody's ever seen the hot dog experiment, but if any part of your finger comes into contact with the blade, a metal brake jams into the blade and the blade retracts almost instantly. And what it does is it prevents your finger from being cut significantly and it prevents amputation. So any table saw we have on campus has to have this saw stop technology. And if you haven't ever seen it, take a look on YouTube or look it up on the internet. They have some pretty cool demonstrations, but we've actually saved probably at least a half a dozen fingers by using this on campus at this point. So the picture on the bottom or the top right is the grinder that I was talking about earlier. Grinders come equipped with a guard. You have to have that guard. You have to maintain that guard on the grinder if you're going to use it. And I think everybody can see on the bottom right, there's a picture of a tamper with a belt exposed. So if you get near that, your pant leg gets near that, something like that, you can get drawn into that actually pulley system, okay? So if you're going to do any type of digging, you have to call New Jersey One Call. I don't think it's really the responsibility of any of people that are on this call, but if or on this Zoom training, but your supervisor should be doing this. And if you have a question whether or not that's happened, you can certainly ask that. You have to call at least 3 full working days before excavating. Must be called even for emergencies. All right. So, and the reason they do that is you want to know what's below the ground you're digging into. All right. All right, so one of the things that you're going to do a lot of, my guess is you're going to do a lot of material handling and lifting and carrying things around. So one of the things we always talk a lot about during these training sessions is safe lifting and material handling. Because you'll be doing a lot of material handling, it's really important to understand the process of safe lifting. We've had many injuries in the past that involve material handling, and essentially what happens when you hurt your back or something like that, it becomes a pretty significant injury and it takes a long time to recover from. So we want you to understand how to lift properly. So the first thing you want to do is warm up. Not saying that we're professional athletes, but if you think of a professional athletic event, if you've ever been to one, what's the first thing they do before they start competing? They go out, they walk through their process, they warm up, they stretch, they get the blood flowing to their muscles, they get their head in the right place, they do all those sorts of things. So you should be doing that as well when you come before you start carrying stuff, all right, and moving stuff. You want to stand as close to the object as possible, and I'll show you a slide in a second that illustrates why that's important. You bend with your knees, keep your back straight, your chin up, get a firm grip on the object. What happens if you start to lose your grip on the object? Should you try and catch it? Or should you just let it hit the ground? You should just let it hit the ground. There's nothing that you're going to be carrying that's going to cost more to you personally or more to the university financially than to get your back returned to the condition it was before you got injured. So if you're carrying something, you lose control of it, let it go, let it hit the ground. All right. So now we have bent knees, our backs are straight, our chins are up. We have a firm grip on the object and we lift with our legs. Our legs are the strongest part of our body in the lifting mechanism. So you want to make sure that you lift using your legs. And we've seen a bunch of injuries over the past where people get to the place where they're carrying whatever it is, and they don't really think about how they're carrying. They thought did a great job about picking it up, carrying it, doing all the right thing, and then they just flop it down. And what you really need to understand is you have to put it down with the same care and thought that you did when you picked it up. All right, so you have to plan your route. You want to keep your object close to your body, avoid slippery locations. If you see a situation like in the top picture here, you shouldn't be walking that way, and you should find that location prior to actually carrying something, because you should have taken a walk through your route, planned it, and made sure that there's no obstructions. Get help with heavy items, team lifts. And the most important thing about a team lift is communicating. So you have to decide who's going to be the coordinator of that lift. You want to make sure that everybody understands when you're lifting on 3, not what does it mean 1, 2, 3, or is it 3 or whatever. You want to make sure that you understand when you're lifting and how you're going. So this is the chart I was telling you about. Force is equal to mass times distance. If you look at the very left, there's a person standing upright. There's about 80 pounds of compressive force on their back. And as you go across this chart, you can see what happens when someone picks something up. So someone holds up a 20-pound object, like approximately 10 inches from their body, and you have 170 pounds of compressive force. And if you look, that's still in the green. So there's still low risk of injury. Now you move that object 20 inches away and you see that the compressive force goes even higher. Still a low risk of injury, but once you get to a person who's bent improperly, picking up a 20-pound object 20 inches away from their body, there's 635 pounds of compressive force exerted on their back, and you can see that their risk of injury is super high. So I think that makes sense to a lot of people, but if you look at the next column over, there's a person been improperly picking up a 1-pound object 20 inches from their body, and there's a moderate risk of injury. A 1-pound object in that case causes 460 pounds of compressive force on your back. So if you think about how you would use a drill is probably 1 pound, screw gun, something like that. If you're holding that far away from your body, there's a lot of compressive force on your back. So you want to keep objects as close to you as possible. Hopefully that makes sense. All right. Some of the don'ts: don't lift and twist at the same time when you're carrying something. Don't try and catch falling objects. I'm stressing this because it happens all the time. It's natural instinct when you start to lose control to try and catch it. Let it go. Let it hit the ground. Don't exceed the lifting requirements of the job. So many of you are transfers from dining, and as such, you probably had different lifting requirements. So you might want to make sure that you check with the supervisors and understand what the lifting requirements will be, and not exceed those. All right, you can get mechanical aids to help with heavy things. Upper right-hand picture here, we have a lift gate. I think just about every shop has the ability or access to a lift gate. The lower left is a actual stair climber. You can operate this stair climber basically with one hand, and it will climb up and down the stairs with up to like 500 or 600 pounds of material on it. It's very easy to operate, but it's something that we got as a mechanical aid to help with moving heavy things around. For you guys in the mason shop, these stone magnets, several years ago, we were having a lot of issues with people doing some of the blue stone and getting hurt backs, hurt fingers, that sort of stuff. So we did a little research and we came up with these. Actually, they're called stone magnets, but they really work on a vacuum system. So you can vacuum them right to the stone, and we take our fingers and we take our backs completely out of this equation. So it's all a mechanical aid doing all the lifting. When we talk about mechanical aids, we want to push rather than pull. So if you think about how the pushing one of these items here, either the pump jack or the hand cart, you think about pushing it rather than pulling it. If you're pulling it, you're using your back and your shoulders. If you're pushing it, you should be using your legs. So hopefully that makes sense. It's a lot easier to demonstrate this when we're in person, but we're not there. So All right, so let's change the focus a little bit to ladders. Some of you will be working on ladders. Um, Step ladders have to be fully extended and locked. The spreaders have to be fully extended and locked in place. They should not be used as a straight ladder unless there are a few ladders. I believe there's some in the carpenter shop and some in the electric shop that are designed to be used as a straight ladder. If you're not sure about it, make sure that it stays extended and locked. All right. Maximum work height. There are maximum work heights for step ladders. If you look at this picture on the lower left, that is not the maximum work height of a ladder. Usually, if you look at a ladder, it says do not stand or sit above these steps, and it's usually the top two rungs of the ladder, depending on the height. And the reason that they have that there is so that once you step above those two steps, it becomes extremely unstable and more likely to fall, as you can see in this picture. No climbing on the back of the ladder unless the ladder is designed to support that. And you can see this picture on the right. It's a little bit kind of crazy, but it is an actual person doing that. It wasn't on campus, thankfully. When we talk about straight ladders, there's a certain angle that we have to have. The ladder, and there's a couple other things as well. The ladder should extend at least 3 feet past the roof edge or point of support. And the reason that is when you're going up the ladder, you have to get on and off of the ladder, and that gives you a hand grab to get on and off of the ladder. The height of the ladder should be 4 times the length of A. That kind of doesn't make a lot of sense when you look at it this way. But if you look at the lower right picture, this is really the easiest way to determine you have the right angle. So if you stand with your feet at the base of the side rails and put your arms straight out, they should rest comfortably on the rungs. It'll give you about a 75.5-degree angle. And in that 75.5-degree angle is the proper angle for climbing. If you think about it, and that angle is too steep, as you climb higher and higher, it's more likely to tip back. And if it's too flat, it's not good either. You kind of put different stresses on the ladder. A couple other ways to check the angle of the ladder. There is an app through the National Institute, through NIOSH, sorry, that if you download it, you can put it right up on the ladder, and it will tell you if the angle is right or not. But the easiest way is to look at the person having their arms outstretched. It makes the most sense. You always have that there. They do have stickers that they put on some ladders, but I will tell you there's quality control issues on those. So typically, if you see one of those stickers, you should always check it. Put your feet at the base, put your arms straight out. That should give you the angle that you want. So here's a couple examples of ladders that are damaged or in some way should not be used. So if you look in the upper left-hand picture, the yellow ladder, someone has altered that ladder. You need to inspect your ladder before you use it. And if anybody would inspect any of these ladders in this picture, you would probably see that there's issues with them. So if you look in the upper left-hand picture, there's a rip of plywood that's installed on that ladder that alters the characteristics of the ladder. The manufacturer didn't put it there, so that ladder would have to be taken out of service. If you look right below that, I think everybody can see that the support of that ladder is very bent and damaged and probably will not work under any kind of weight. So that ladder should be replaced. The bottom right, this ladder was actually in use going onto a very high roof when I saw it. It looks like someone hit it with a hammer or something to that effect where the ladder was damaged. And that ladder is a weak spot at that point. So that really easily could have collapsed and caused really some significant injury. The upper right, you'll see that there is a cut in the rung. Again, that's something that weakens the ladder. Now this ladder, the next one over, is actually, it says it has a bent frame. It's tagged out of service, and that's really great. But if I'm in a pinch and that's the only ladder around, I'm likely to use that. So I'll show you how to properly dispose of a ladder that's damaged in a minute. And you can also see the next ladder over. All ladders are rated for certain weights. So I don't know if anybody knows me, but I'm not going on this ladder. All right. So 225 pounds is not the appropriate weight rating for someone like me. And That's because I'll be carrying so many tools, and all the tools and materials that I carry up that ladder equal that weight. So I'm not going to hit that. A couple examples of what not to do when on a ladder. You can see that the picture on the left, they are two people on the ladder. The angle is not proper. It's a step ladder in a folded position, and they're both leaning outside of the ladder. So the rule of thumb when climbing or working from a ladder is keeping your belt buckle between the side rails, and that will help you with stability. You can see that both of these guys have their belt buckle outside of that, and it's likely that that ladder will kick out. I think we've all done what the person on the right has done. We've used a step ladder and gotten close to where we wanted to and climbed up. And it's kind of easy to go that way, but coming down, there's always that blind step. So you shouldn't be doing anything like that. And if you think of that in terms of a straight ladder, that's why OSHA mandates that we have a hand grab, and it extends 3 feet past that where that gutter would be, so you can get on and off easily. All right. Some climbing guidelines: wear footwear with clean, non-skid soles. Keep rungs clean of mud or grease. Have a stable base for your ladder. Avoid overreaching, which is what I just talked about with keeping your belt buckle between the side rails. And you have to maintain 3 points of contact when climbing. All right, so that's 2 hands and a foot, or 2 feet and a hand. All right, you want to store ladders horizontally. Major repairs must be done by properly trained people. There is no one on our campus that is properly trained to repair a ladder. If the ladder is damaged, it must be taken out of service. Mark, danger, do not use, and destroy ladders that can't be repaired. So if you see that that ladder is damaged, you can see in this picture on the left, this is the proper way to destroy a ladder. This ladder cannot be used again, all right? And dispose of painted wooden ladders. We don't use wooden ladders generally, but a painted wooden ladder hides all the defects and splits and anything that could happen to that ladder. All right. One of the things that you have to be aware of is electrical safety. When we talk about electrical safety, we're talking about shock becoming part of a circuit. We're talking about fire, and we're talking about arc flash. Arc flash should not be something that you're exposed to. You should not be working near any exposed or live electrical parts, all right? None of you are authorized to do that. Even the people that are in the electric shop right now have not gone through that training, and they should not be exposed to an arc flash. So basically what we're talking about is shock or becoming part of a circuit. So to understand electricity, you have to understand how your body reacts to it. So if you are exposed to 1 milliamp, there's a perception level. So if I'm exposed to 1 milliamp, I can actually feel that. 5 milliamps, there's a slight shock felt. It's not really painful, but it's disturbing. It's considered to be the maximum safe shock allowable by OSHA. And the reason that it's a safe shock and it's allowable by OSHA is because there's no permanent damage created by that shock. All right. So 6 to 30 milliamps, if you're exposed to that, it's a painful shock. And basically what it does is it helps to contract your electrical circuits in your body. And essentially your muscles will contract, and you will grab onto whatever that, you will become a part of that circuit. And as you're becoming a part of that circuit, and if you can't let go of it, the longer you're a part of that circuit, the longer you're cooked, essentially. So the more pain, not only the more pain, but the more permanent damage that can be, you can have. 5 to 150 milliamps is extreme pain, respiratory arrest, severe muscular contraction. All of these things are pretty significant from this point on. So just to give you some perspective, 1 milliamp is 1/1000th of an amp. 15 1,000th or 15 milliamps causes that can't let go reaction. And there's 20 amps available in your standard residential panels. So what basically this is saying is that you shouldn't mess around with electricity, and you shouldn't be playing in your panel, all right? Because your panel can kill you. So if you look at the picture in the middle here, this is a picture of the person back in the day when you were allowed to use human test subjects. This is the person that helped them discover what electricity does to your body. You can see that he's in probably somewhere in the 5 to 150 milliamps, where he's extremely contracted, and he's being shocked in a very probably inhumane way. The picture on the left is what we call Ohm's law, where current is equal to voltage divided by resistance. don't really need to understand this in terms of the equation, but what you do need to understand is that electricity and water don't mix. So if there's water, whether there's sweat on your skin or water on the equipment that you're using, there's very little resistance to the water. If you have dry skin, there's much more resistance, and if this area is dry, there's much more resistance, so that there would be less of a exposure to the current. All right. So when we talk about electrical safety, it's about how we handle the equipment. Again, we should be visually inspecting it. You have to use a grounding type equipment. You can see in this picture that this guy has his feet in water and he's messing with electricity. If that's live, that guy's probably has a death wish. You need to use a GFCI or a ground fault circuit interrupter when you're using any outdoor equipment. And you see a couple pictures of the yellow GFCIs here. Circuit breakers are designed to protect equipment. So if a circuit breaker pops for some reason, there's an overload, and it's designed to protect the equipment from being damaged. A GFCI is designed to protect human life. So the way that the GFCI works is it monitors electricity, it monitors the circuit. If there's any change in that circuit up to a couple milliamps, what it does is it opens up and goes to ground, or it closes and goes to ground, much like a circuit breaker would pop. So you have to be using a GFCI when you're using outdoors equipment. The GFCI should be plugged in at the source. So the GFCI should be plugged into the wall, and then if you have anything running from that plug out is protected. So if there's any kind of leakage of current, then it's going to trip and you'll be protected. If you have that plugged in by your tool and you have an extension cord going out to that GFCI, basically there will be a portion of that circuit that is unprotected from the GFCI to the source. So make sure you plug it in at the source. Some of the examples of electrical hazards: defective insulation, damaged tools and equipment. You can't use cords to lift supplies and equipment. So if you see a outlet like we see in the middle, what's the easiest way to unplug that? What do you think you could do? You could grab both sides of it, and when you grab both sides of it, you're going to get zapped. All right. The equipment on the left would need to be repaired. That the cord. What about the drill on the right? If you're using that drill and there's an exposed wire of some sort, which in this case there is, that drill is not double insulated. It's basically a metal drill, and I think we've all used drills in the past that are metal drills, and we've all been zapped by them a little bit here and there. But we shouldn't be using anything that's not insulated. Some electrical hazards. Ground pins have to be intact. If you look on the left, there is a picture of a plug without a ground pin. The upper picture, you can see damage to the cord. That cannot be used. And the right-hand picture is actually a cord that I saw in the used store several years ago, before they did all the renovations. That cord was probably the worst cord I've ever seen. You can see that it's taped. You can see that it's been stretched and with all the pigtail looking curls in it. You can see wires sticking out. You can see the duct tape on it. Hopefully we don't see anything like that bottom picture anywhere on campus. Some other examples of electrical hazards. If you overload a circuit, you can create a fire. And here's a couple examples of overloading. The one on the left is pretty common overloading thing you see around Christmas time. And here's just kind of a silly picture of some electrical hazards and the way some guys deal with that sort of thing. All right, so we've talked about a lot of the hazards that you may come into contact with and how you prevent yourself from being hurt by them. But some of the things that it's really important that you understand that you're prohibited from doing. So in other words, you can't do this. You can't use a fire extinguisher unless you've been appropriately trained by the fire marshal. So there is a training that is provided for the use of fire extinguishers, and unless you've had that, you cannot use a fire extinguisher. All right. You can't get help. Call 911. Get public safety involved. That's the way to deal with that sort of situation. You can't enter into a confined space. I'm going to tell you what a confined space is in a minute, but you cannot go into one. Again, we already covered working on or near exposed electrical circuits. This can create an arc flash, which is extremely deadly. You cannot be working on or near an exposed electrical circuit. You can't be operating a forklift unless you've been trained to do so by someone in my office. You can't apply or remove a lockout tagout device. Lockout tagout devices are devices that are put onto electrical circuits to lock them out of service so that people working on them can be safe. If you remove a lockout tagout device and turn something on, there's likely someone down on the other end of that, somewhere downstream of that you just probably shocked and maybe fried. So you want to make sure you don't do that. And I'll show you an example of what that is. And you can't perform work that requires fall protection. We'll talk about all these things right now. So what is a confined space? A confined space is a space that's large enough to bodily enter and perform work and has a limited means of entry or escape and is not intended for continuous human occupancy. So when I talk about this, you'll see these big blocks that say and. So a confined space has to have all three of these characteristics. In other words, it has to be large enough to enter and work, it has to have a limited means of entry or escape. Limited means of entry or escape can mean a ladder, a man door, a small crawl space, an access door, anything besides that of a regular sized door. And it has to be not intended for continuous human occupancy. So when we talk about continuous human occupancy at the university, we're talking about lights and ventilation. If it has lights and ventilation, it's intended for continuous human occupancy. So hopefully that makes sense. No one should be going in a confined space. Examples of confined spaces around campus: tanks, manholes, boilers, furnaces, sewers, vaults, pipes, trenches, tunnels, ducts, bins, pits. All of these things you are prohibited from going into. And one of the big hazards of this is an atmospheric hazard. And basically what happens in some of these spaces, the oxygen gets used up. So if there's not available oxygen, less than 19.5%, you start to have adverse health effects, and greater than 23.5%, if there's an oxygen enriched atmosphere, it becomes very explosive. There can be flammable gas buildups in these spaces. Airborne dust meeting or exceeding the LEL 5-foot rule. Toxic atmospheres, carbon monoxide, hydrogen sulfide. There's all kinds of things that can happen in one of these confined spaces that are very dangerous. And if you don't know what you're doing, and you haven't been trained and you don't have the proper equipment, some of the proper equipment would be a atmospheric monitor to know what is actually going on in the air. You shouldn't be going into them. Lockout tagout. This is what I was just talking about. It's the control of hazardous energy. It's used when servicing and maintaining equipment and machines. It prevents the unexpected energization or startup of the machines or equipment when someone is working on or around that machine. It prevents the release of stored energy that could cause injury. It's required by OSHA regulations. So if you see a tag like this, danger, do not operate. Do not remove that lockout tagout device. It's likely somebody's working downstream of that, and that device and lock and tag are there for a reason to protect them. So if you see that and you have questions, ask your supervisor. And the last thing I said we talk about is falls. And really what you need to know is falls are the second leading cause of fatalities behind transportation accidents. Falls to a lower level accounted for 81% of the fatalities, and approximately 25% of those fatalities occurred after a fall of 10 feet or less. So what that's telling me is a quarter of the fatalities associated with falls happened less when someone was less than 10 feet. So most likely a lot of those people were on 6-foot ladders. So if you think you can go on a 6-foot ladder and not be killed, think again. Half the people that are killed in the workplace are on 20, or not half of them. A quarter of the fatalities occurred less than 6 feet. Obviously, roofing fatalities are going to be one of the highest fatalities in terms of types of jobs. Buildings and grounds maintenance, which you guys will be doing, are 27% of the fatalities are from fall slips and trips, and construction is a higher percentage of fatalities. So when the falls occur, when you're loading or unloading material, climbing up to or down from an elevated position or location, if you're walking, stepping from one surface to another, walking backwards, if you're distracted, working from a ladder, basically anytime you're working at heights, a fall can occur. So some of the physics of falling, if you think you can catch yourself, basically you can't. It takes an average person 3/4 of a second to react. Acceleration due to gravity equals 32 feet per second squared. After 3/4 of a second, you fall in 9 feet. After 1 second, you fall in 16 feet and you've reached a speed of 32 miles an hour. 2 seconds, 64 miles an hour, and you fall in 64 feet, et cetera, et cetera. So you're not going to react, all right, in time to grab yourself. Some of the things when fall protection is required: fixed ladders is 20 feet, elevated surfaces is 4 feet, supported scaffolds would be 10 feet, suspended scaffolds anytime you're on a suspended scaffold or anytime you're on an elevated personal platform, you need to have fall protection, and anytime there's a vertical opening. So if you're exposed to any of these things, you need to tell your supervisor you can't do that. You need to back away from it until fall protection is available. All right, so what you need to know is you're prohibited from performing work that requires fall protection equipment unless you've been trained to do so. We have a website, ehs.princeton.edu. Has a lot of this information on it, but I'm always around if you have questions. There's also a great source for other types of safety related stuff that you may occur even not only while you're transferred, but maybe back when you're back to your home department. So hopefully
that says seasonal employee industrial hygiene training. And so all industrial hygiene means is I'm just going to talk about subjects that deal with preventing you from being exposed to hazardous substances, particularly chemicals. But we're also going to talk about, with some of you, exposure to excessive noise that has the potential to damage your hearing. We're going to do that at the end because not everybody that is part of this training needs to have that. So I will be dismissing some of you towards the end after we talk about the chemical safety part of this and the asbestos part of it. All right. So the three things I want to talk about: first, personal protective equipment as it relates to protecting you from hazardous materials. Then I'm going to talk about general chemical safety, which we call hazard communication. And then a little bit about asbestos awareness. Then I'll dismiss some of you, and then we're going to end it with a discussion about hearing conservation. So I just wanted to generally go over personal protective equipment and the broad categories of it that are available to you based on the hazard that you could be exposed to, and that the recommendations for that are based on a hazard assessment that's done by the department that you're working in, as well as in conjunction with EH&S. And so there will be different types of eye protection available to you, perhaps even face protection, namely a face shield. Also, some of the work you do may require special footwear, particularly safety-toed shoes and gloves. Those gloves may be chemical-resistant gloves, or they could be work gloves. Another category of personal protective equipment is respiratory protection, and that is a category that is highly specialized. And those of you who are working now in the summer are prohibited from doing activities that would require a respirator. But I did want to point out that that is part of the categories of personal protective equipment. And then lastly, there's hearing protection. So I mentioned that there are some of you working in shops that are part of our hearing conservation program because of the level of noise that you're exposed to. But even if you don't work in that shop, in those shops, there may be some activities where you may want to wear hearing protection for comfort. So let's jump into the specifics of these different types of personal protective equipment. So a little bit more about eye and face protection. So when we look at eye protection, we can break it into three categories. There's either safety glasses, which are outfitted with side shields. And you would wear safety glasses in situations where there's a potential for small particles or liquids to sort of splash or fly into your eye. Okay. So those are available to you for those circumstances. And you would want to wear a goggle, a safety goggle, which is more protective than safety glasses, in that it provides protection around the complete perimeter of your eye. Now, there are goggles that are more appropriate for chemical splashes when you're using large quantities of chemicals. And then there's also goggles that are vented that would be more appropriate to wear in dusty environments. So depending on which hazard you may be exposed to, you would have either of those two options available to you. And lastly, there's face shields. Face shields are appropriate in conditions where you're doing something where large particles could fly into your face, okay? So some examples of that might be weed whacking, or there may be certain chemicals that you use in large bulk quantities where there's a potential for splash. Where you would need to wear a face shield in addition to eye protection underneath, whether that be safety glasses or goggles, depending on the hazard. No matter what the case is, if you're wearing a face shield, you still need to wear eye protection underneath. All right, a little bit more about gloves and the different categories of gloves. So for the chemical resistant category, there are many types of chemical resistant gloves available. Some are disposable, some are not. They're made of different types of materials, and the type you would use is really dependent upon the chemical hazard that exists. So you want to make sure that those gloves are compatible with the chemical that you are wearing them for protection against. And again, this is something that you would look for your supervisor to guide you on. There's also gloves that are not chemical resistant, but are helpful when you need to lift and move and grip things. Or if you are working with sharp objects, there are cut resistant gloves that are available as well. In addition to making sure the glove is compatible with the hazard, you also want to make sure that it fits you properly, because if it's too small or if it's too large, it can also create a safety concern as well. It can slip off, or if it's too tight, it can affect your circulation. So again, we want to make sure that it fits you properly. I mentioned already that respiratory protection is not a type of personal protective equipment that you should need working here over the summer. However, you may see some of your colleagues who work here year round do tasks that require a respirator. But again, you should not be conducting any tasks that require a respirator, or be working around others who are conducting tasks that require a respirator. All right, a bit more about hearing protection. So there are different types of hearing protection available, and the two primary types that you'll have options to wear will be either an ear muff or an ear plug. The ear plug options available to you are disposable. So what that means is you would at a minimum get rid of them at the end of your work shift, but you may need to change them out more than that if they become dirty, or they no longer work the way they should. Ear muffs are reusable, so they require maintenance and care. Most importantly, they'd have to be kept clean, so you need to wipe them down with soap and water periodically. And also, how well hearing protection works is directly related to how well it fits you. So if it's an earplug, how well it fits inside of your ear versus an ear muff, how well it fits over your ear. Okay. And so instructions on how to put on an earplug are typically on the packaging for the disposable earplug. And then the ear muff is pretty self-explanatory, but the instructions are usually on the box for the ear muffs. Okay. I'm going to pause here to see if anyone has any questions about personal protective equipment. You can unmute yourself if you would like. Okay, not seeing any questions, so I'm going to move on. Okay, so the next topic that I want to discuss is what we call hazard communication. Okay, also known as chemical safety, also known as right to know. And for those of you who have worked with us in the past, this should be nothing new for you. But what this subject is, or where this subject is coming from, is actually coming from a regulation or a standard that was passed by an organization, a federal agency called OSHA, the Occupational Safety and Health Administration. And they have several regulations in place to protect you, to protect workers. And they created this standard called the Hazard Communication Standard, also known as HAZCOM, back in the 1980s. And it was created so that workers who have the right to know what hazards are that they could be exposed to in the workplace, that there's to make sure there's a mechanism in place for them to understand what those hazards are. And so what that standard mandates is that the health effects of a chemical you might have to work with, which are those effects that can make you sick or cause an illness, are communicated to you, as well as the physical hazards of working with those chemicals. So what can cause physical injury or harm to you if you work with that product? Like, is it flammable or explosive? Excuse me. Also, making sure that you understand how to handle the chemical properly and safely and store it. All right. Again, the focus on making sure you as the worker understands what those health and physical hazards are sort of the highlight of this standard. And the main way that this information is going to be communicated to you as the person using it is through what's on the label that's on the container that the chemical is in. Okay, so every chemical container has a label, and that label has information on it that will tell you what the potential health hazards are and what the potential physical hazards are. And again, health hazards are hazards that can cause illness in you, make you sick. So, for example, if something can cause cancer, there will be information on the label that says it may cause cancer. If it can cause eye irritation, there will be a statement on the label that says that. So the label is the first place where those hazards are communicated to you. And then the second place is on what's called a safety data sheet, okay? Or an SDS. They used to be called material safety data sheets, or MSDSs, years ago. But now they're known as safety data sheets, and they are essentially a report on the safety of the chemical that every company that makes a product has to write and put together and make available to the consumer. Okay, and so a little bit more about how this information is communicated to you on the label. When you look at a chemical label, you're going to see obviously the name of the product, but you're also going to notice these symbols on the label. And if you look at this example on this slide, in the top right corner, you see two of the symbols. There's 9 of them that are available, but in this example, there are 2 here. that are displaying what the potential hazard is associated with the chemical. And so, what these symbols are designed to do is if you understand what they mean and you look at the chemical without reading anything else on the bottle, you have a quick understanding of what those potential hazards are. And I'm going to explain each one of the symbols in a minute. Also, you may see on the label a signal word. All right. There may be one of two signal words on a label, or you might not see one at all. The two potential signal words on a label could be danger or warning. If you see danger, it's telling you that that chemical is a serious hazard, extreme hazard. If you see warning, it's telling you that the product is hazardous, but not as serious as a hazard as if you were to see the word danger. Okay. Now, in some cases, you may not see a signal word. So you might not see danger, you might not see warning on the label. And what that's telling you is that the chemical or the product is not hazardous enough to warrant a signal word. Okay. Now, also on the label, there will be statements called hazard statements. And those are brief sentences that tell you exactly what the potential health or physical hazard could be. All right. And if we look at the example on this slide, you'll see the hazard statements under the word danger on the side where the symbols are. It says in this example, the substance is a highly flammable liquid and vapor. Also that it may cause liver and kidney damage. And so you'll see statements like these on the label. In addition to these type of statements, the hazard statements, you'll also see precautionary statements, which are on the left here. And these are statements that are going to tell you exactly what you need to do to protect yourself so that you don't experience any of those health or physical hazards. In addition, you're always going to see the product identification information as well as the contact information for the company that made the product. Okay. Now, on this slide, if we look at the bottom, you'll see 9 symbols across the bottom. These are those pictograms or symbols that I mentioned earlier. And as I said earlier, each one means something. So if we look at the symbol that's in the middle here, what we're looking at is supposed to be a dead fish, a dead tree, and an oil slick. And what this pictogram is telling us is that if you see it on a label, this substance can harm the environment, okay? This is the only pictogram out of the 9 that does not directly relate to a health or physical hazard to human beings, okay? The 4 symbols on the left side of that environmental symbol represent health hazards, okay? So health hazards, again, are hazards that can cause illness or disease in humans. And the 4 symbols to the right of the environmental symbol represent physical hazards. And these are hazards that can cause physical injury or harm to humans as well as property. Okay. All right, now let's jump into a little bit more about what each symbol means. So these are the first 2 health hazard symbols. On the left, we have the skull and crossbones, and on the right, we have the exclamation point. The skull and crossbones symbol, when you see this, it's telling you that that substance is a severe health hazard. And also that it can do harm to you, it can be toxic to you very quickly. So when you see the term acute, all that means is it can do harm right away or quickly after you've been exposed to it. So when you see the skull and crossbones, you'll know that that's a severe hazard that can harm you quickly, versus the exclamation point, again, something that can harm you quickly, but its harmful effect is less severe, okay? Typically, you'll see the exclamation point for health hazards that are reversible. So if you're exposed to it, maybe it's irritating to your eyes or your skin, or your respiratory tract. It might make you cough, but once you're no longer exposed to it, you go back to normal. Okay. Again, those are examples of when you would see those two symbols. Now, two more symbols that you might see on a label related to health hazards. On the left, there's a pair of test tubes with some liquid oozing out of it. And in my opinion, this is one of the most obvious of the symbols. When you see this, it's telling you that that substance can be corrosive to your skin. And if something is corrosive to your skin, it can damage it. It can damage tissue. All right. It can also be corrosive to your eyes as well. All right. Now, the symbol on the right, I call this the head for lack of a better description. When you see this symbol, it's telling you that that substance typically has some sort of long-term health effect. Some examples would be if the substance can cause cancer, if the substance can cause an asthma-like response in your lungs and your respiratory tract. If it could damage any organ in your body, so your heart, your liver, your lungs, your kidneys, any of those organs, or harm your reproductivity or damage your DNA, you will see this symbol on the label. Also, if the substance is an aspiration hazard, which basically means it causes your lungs to fill up with fluid, you will see this symbol on the label. All right, on to the symbols that represent physical hazards. Now, again, physical hazards are hazards that can cause physical injury or harm, and these are very, very straightforward. On the left, we have the exploding bomb. When you see this, it's telling you the substance has the potential to be explosive. Similarly, with the flame symbol, if you see that, it's telling you the substance is flammable. And then a few more physical hazard symbols. You'll notice that the corrosive symbol is back, and it's also representing physical hazards. So you'll see this symbol for a substance that could also be corrosive to metals. Okay. And then we have the gas under pressure symbol that will be on a container that is under pressure. It could be a can. It could be like a can of spray paint, for example, or a can of WD-40. Those types of materials are under pressure. Or it could be a full-size compressed gas cylinder like oxygen or acetylene. And then lastly, for the physical hazard symbols, there's this flame over a ball symbol, which is the oxidizer symbol. Oxidizers are substances that promote burning. So if there's an oxidizer present and there's a fire, that oxidizer is going to make that fire worse. It's going to make it burn hotter and burn longer. Okay. And then lastly, there's that environmental symbol again. Okay. So those are the symbols. You will see those symbols on the container label for chemicals, hazardous chemicals that you might have to work with. And you will also see those symbols on the safety data sheet that I mentioned earlier. I just want to touch on a little bit more about the safety data sheets and the type of information that you can expect to get there. And I want to say that I recommend that you take a look at the safety data sheets for a chemical that you've never worked with. And all you have to do is ask your supervisor for the safety data sheet, and they should be able to get one for you for that product. But every safety data sheet that's written, regardless of what product it's for, has to be written following a standard format. And that format requires there to be 16 different sections to this safety data sheet. I'm not going to go over each of those 16 sections, but what I wanted to do was show you an example of a safety data sheet for a common product that you may come across when working this summer, and point out 3 of the sections out of the 16 that I think would be most important to you. Okay, so section 1 is always going to be the contact information, where the contact information is for the manufacturer, as well as the name of the product. And that's always very useful. Section 2, though, is really what I want to focus on in this slide. And that's the hazard identification section of this particular safety data sheet. And what you'll notice first and foremost, I hope, is that there are 3 symbols here. And without reading any of the wording that's on this sheet, if you look at those 3 symbols, I'm hoping, based on what we just reviewed as far as what each of these symbols mean, you have a quick idea of what kind of hazard this product could pose. So we're looking at a safety data sheet for WD-40. And if we notice the symbols, the first symbol is a flame. And so what that's telling us is that this substance is flammable. The second symbol is the compressed gas symbol. That makes sense because WD-40 comes in a can that's under pressure. And then the last symbol that you see here is what I called the head. And the reason why you see this for WD-40 is because WD-40 is considered an aspiration hazard, which means it can cause your lungs to fill up with fluid if you're exposed to it. So again, the way these symbols are designed to work, you look at them and you have a quick idea of what the potential health or physical hazard is. The other thing that you'll see in this section of the safety data sheet is the signal word. So you'll see that it says danger, which means that it's a severe potential hazard. And then you'll see those hazard statements that I mentioned. It says this substance is extremely flammable. It says it's under pressure. And it says it may be fatal if swallowed and enters airways. And then as far as prevention, it tells you what to do to prevent or minimize being exposed to it. It says keep it away from heat or sparks. Tells you what to do from a first aid standpoint, tells you how to store it so that you don't create more of a hazard when you're using it and storing it. So section 2 of any safety data sheet is going to be the hazard identification section, and that's going to be where you go to get more information about the specific hazards associated with the product. Section 4 of any safety data sheet is the first aid section. Again, a really important section if you are exposed to something, if you get it on your skin, if you get it in your eyes, if you inhale it and you feel like you're experiencing symptoms. You always want to look at section 4 on the safety data sheet. And then the last section that is very useful is section 8, which is the exposure control section. This is where you're going to go to get more specific information about the personal protective equipment that you should wear when you're using this product. So we talked about the different categories of personal protective equipment earlier in the presentation. But this is where you're going to go to find out what type of eye protection, what type of gloves you might want to wear, and whether or not a respirator is recommended or not. Okay, so section 8 is also very useful. Okay, now some basic rules with handling hazardous chemicals. Don't mix them unless the manufacturer's instructions on the label tell you to do so. If it's a product that needs to be diluted with water, you always want to follow the instructions on the right dilution strength and don't make it a stronger dilution in the hopes that it will work better. When you do that, you in fact could be creating a hazard, okay? You always want to use hazardous materials in areas where there's good ventilation. And you always want to wear the correct personal protective equipment, which your supervisor should be able to advise you on, but you should also look at the chemical label and the safety data sheet on your own to confirm that you are wearing the correct personal protective equipment. All right, a little bit more about basic first aid, okay? So if you get a chemical on your skin, the first thing you always want to do is rinse that area for at least 15 minutes with water. And you want to remove any clothing that is in the way of that water having direct contact with your skin. Similarly, with a chemical splash to the eye, you want to rinse that area with water for 15 minutes while holding your eye open. And if you wear contact lenses, you want to remove those lenses while you're rinsing. And you want to rinse away from the center of your face, so away from your nose, so that if there's only contamination in one eye, it doesn't move and rinse over to the other eye that is not contaminated. If you inhale something that is causing you symptoms, you want to go to an area where there's fresh air. If you swallow or ingest a hazardous material, you want to, before you induce vomiting, you want to consult the safety data sheet, or seek medical advice first before you induce vomiting, because that could do more damage. Okay. And in all of these cases, you want to report your injury to your supervisor immediately, and they also have to be reported to occupational health at McQuaid. Okay. So that was the end of sort of the hazard communication chemical safety piece. Now, this next topic that I want to review is just a basic discussion about asbestos awareness, because some of you may be working in areas where asbestos is present, and we want you to understand that, first of all, just because asbestos is present doesn't mean that it's hazardous to you, but there are things that you need to do so that you don't create an asbestos hazard. Okay. So I first want to start off with an explanation of what asbestos is. Okay. So it's actually a naturally occurring material. Okay. So it's not man-made. It's not produced in a laboratory. It's actually mined from the earth. And these are some images of what asbestos looks like in its raw form. So it's actually a rock that's mined. And then if we take that rock and we put it on a slide under a microscope and we look at it very closely, this image in the top left corner of the slide is what it looks like up close. And as you can see, it resembles pins and needles. So you can't see asbestos fibers. These are the fibers that are within the rock. But when you magnify them, they have this pins and needle structure. And what makes asbestos hazardous is when it's inhaled in its raw form, or ingested in its raw form in large quantities over extended periods of time. It can cause damage to organs in the body. Okay. And so specifically and most commonly in the workplace, asbestos exposure happens by inhaling it. And over time, if a person inhales it repeatedly, then it can cause damage to the lungs. And that damage can lead to some specific diseases that are associated with asbestos exposure. Okay. Those diseases are asbestosis, which is a scarring of the lung tissue. It's not cancer, but when the scar tissue builds up, it can make it extremely difficult for a person to breathe. Lung cancer can also occur from repeated exposure, and that's where abnormal tumors can grow in the lungs. And eventually cause the lungs to fail. And then lastly, the third disease that's associated with asbestos exposure is mesothelioma. And this is another type of cancer that can occur in the deep lining of lung tissue, where special cells called mesothelial cells exist. And then I just want to talk a little bit about what puts a person more at risk of developing one of those diseases. So it's it's a combination of things. It's the type of exposure they had, right? So when asbestos is mined, it is taken in its natural form, and it's put into different types of materials. And here in the United States, it was mined from, as far as we can tell, the early 1800s right up until about 1980. And it was put in a lot of different building materials. And depending on the material that it was put into, it could be in a form where it doesn't take a lot of disturbance to release those fibers that I showed you in the earlier slide. So if a person is exposed to a form of asbestos where those fibers were easily released, versus a person who was exposed but to a form of asbestos where it was tightly bound, and those fibers were not easily released, that factors into whether they develop one of those diseases, as well as how much they were exposed to and how long they were exposed to it. So, were they exposed for just a couple of days in their whole lifetime, or was it several days, over several weeks, over several years? All of those things factor into whether a person develops one of those diseases, as well as smoking. Smoking has sort of a magnified effect, also known as a synergistic effect, on a person. So if a person smokes and they were exposed to large quantities of asbestos over an extended period of time, they have a higher probability of developing one of those diseases. And unfortunately, smoking has that type of effect on a lot of other exposures, not just asbestos. Okay. So I mentioned earlier, asbestos was manufactured in many different materials. It was mined and it was placed in many different materials. Upwards of 3,000 different types of materials may have asbestos within it. And here at the university, this is a sort of a short list of where we tend to see it. Okay. But what I want you to remember, if you don't remember anything else from this presentation, is that if you are working in or on a building at the university that was built before 1981, you need to assume, before you do any work that could disturb it, that there's asbestos in that building material. And you should not move forward with doing that work until you've confirmed whether or not that material has asbestos or not. Okay. And so you would confirm that through asking your supervisor. And in most cases, your supervisor, before they ask you to do the work, is going to check this. Okay. So 1981 is the cutoff date that we use here at the university for buildings that may still have asbestos in it. So just remember that. Okay. And in terms of who is going to confirm whether that material has asbestos or not, that is my office, the Office of Environmental Health and Safety. There are a number of us, including myself, who have special training and experience in asbestos testing or sample collection. So we collect samples and we send it out to a certified lab who will test it for us and let us know if there's asbestos in it. And we also keep records of what we've tested in the past. So in many cases, if you reach out to us and ask us about whether something has asbestos, we can check our records and let you know without even taking a sample. Okay. Now, I am not telling you all of this to scare you. We just want to inform you that you may be doing work around asbestos-containing material. And because of that, we want you to have some knowledge about asbestos, as well as understanding that as long as you're not doing anything to damage it, it's not a hazard. Okay. So if, for example, you're in a room and there's asbestos on the walls and the plaster, as long as you're not doing anything to disturb that wall, like sand it or demo it, you're not being exposed to asbestos. Asbestos is not a hazard unless it becomes damaged, which means there's a potential for those tiny fibers to be released into the air. All right, so just because it's there, as long as it's intact, it is not releasing fibers that can be harmful to people. All right, in addition to environmental health and safety and asking your supervisor about what may contain asbestos, we also have postings in mechanical rooms across campus that provide some basic information about what is known about asbestos in that space. And we also have a summary of asbestos containing material that we provide to supervisors and managers across campus. And they have access to this and can share it with you as well. If you are doing work in some of the locations that are in it, it's a great place to look before you move forward with that work. So, in summary regarding asbestos, if you see any damaged material in a building that was built before 1981, we want you to let us know. Let environmental health and safety know, let your supervisor know. If you see any questionable activities, so what do I mean by that? I mean, if you see other people doing things that could damage or disturb building materials that might have asbestos, you need to notify EH&S, at the very least notify your supervisor. If there is something that you think could have asbestos, but you're not sure, we don't want you to take a sample of it. We also don't want you to clean up anything that you find, any disturbed building material that you think might have asbestos. We just want you to report it so we can have it handled appropriately. And the other thing I want to point out is that the university is constantly undergoing renovation and construction all across campus. And as you're probably aware, many of the buildings built on this campus have been here before 1981. And so we do a lot of asbestos abatement when we renovate, because renovation will cause disturbance. And so we have licensed abatement contractors on campus all the time. And they set up enclosed abatement areas, and they are the only ones who are authorized to go into abatement areas, okay? No one else on campus. Those of you that I asked to stay, the reason why is because you work in a shop where our assessment of your noise exposure has determined that the level you'll be exposed to could exceed what OSHA says is safe, okay? And so the people who are dismissed, they work in groups where their noise exposure doesn't exceed that, or they're not going to be doing tasks that would expose them to noise levels above that. All right, so that is why you're still here. And we're just going to quickly go over a few things related to what we call the hearing conservation program. The reason why you're having this specialized training is because we want to make sure that while you're here, we don't damage your hearing in any way. And so that's what we're going to focus on. And you'll also find that you're going to have hearing tests before or towards the beginning of your start. So in the next week or so, you'll be asked to go get a hearing test up at Occupational Health at McQuaid. And then before you leave at the end of the summer, even if you're transferring to a different back to your original position, you will have to have a final hearing test. Okay. So just to begin things, I just want to briefly explain what noise is. Okay. And the basic definition of noise is that it is unwanted sound. Okay. Typically, it's sound that's considered a disturbance or unpleasant. And there are two components to sound. There is the frequency of it, which is also known as the pitch, and that is measured in hertz. And then there is the intensity or the loudness of it, which is measured in decibels. Okay. Both of these components of sound are important, though most of us are probably only familiar with the decibel part of it. The pitch part of it is familiar as well. So, sound pressure level. Sound pressure level is simply how we measure the intensity of sound, i.e., how loud sound is. Okay, and that's what's measured in decibels. And the way sound operates, the way sound waves operate, is on a scale that's called the logarithmic scale. And the reason why I point that out is because it doesn't take much of an increase or decrease in the intensity or the loudness or the decibel level of sound for the human ear to perceive that as being much louder or much quieter, because sound operates on the logarithmic scale. Okay. So let's just quickly go over how our ears work, okay, how we hear, all right? And if we look at the image on the screen and we look at our external ear here, it acts like a funnel. And so when it detects sound, it collects it like a funnel, and that sound goes down the ear canal, and then it hits this structure right here that vibrates. This is the eardrum. So when the sound hits it, it vibrates, and then it transmits electrical impulses into this shell-like structure, which is called the cochlea. Now, inside of the cochlea are these tiny little nerve cells called cilia, or also known as hair cells. And those nerve cells will move and generate electrical impulses that will go down this nerve here called the auditory nerve, which travels to the brain. Okay, so that's how the ear works. And when there's any damage that happens at any part of this process within our ear, it can lead to hearing loss. Okay, so when is noise too loud? There's been a lot of different scientific studies that have taken place over the years. And what those studies have found is that if a person is exposed for long periods of time, namely an average of 8 hours a day, to noise levels at or above 85 decibels, then it's possible for damage to occur to their ear. Okay, so it's the loudness of the noise, it's how long the person is exposed to that noise, as well as their distance from the source of the noise, that all factor into whether a person experiences hearing loss. Okay, and again, OSHA has determined, or scientific studies have determined, that 85 decibels is sort of that baseline level of noise that once we start to see a person exposed to that for a prolonged period of time, damage can occur. And OSHA, the Occupational Safety and Health Administration, has based their hearing conservation standard on this. Okay, and so this is a summary of OSHA's hearing conservation standard. They've made 85 decibels averaged over an 8-hour work period their action level, and 90 decibels averaged over 8 hours is their permissible exposure limit. And what those numbers mean is that if a worker is exposed at or above those levels, we have to include them in the hearing conservation program. And that's why you're here. That's why we're doing this training. And that involves training. It involves providing you with hearing protection. It also involves you getting hearing tests. Okay. All right. Some of the effects of exposure to loud noise, depending on how loud the noise is, as well as how long the person is exposed, will directly relate to the type of hearing loss they experience. So that hearing loss could be permanent or long-term, or it could be temporary. It just depends. In addition to hearing loss, another effect of exposure to loud noise is tinnitus, which is often detected as a ringing in the ear. Okay, so what this slide is showing is our images of those hair cells that I mentioned earlier up close. If you look on the left side, those are healthy hair cells. If you look on the right side, those hair cells were exposed to noise, and you can see that they're kind of damaged. And so we want to make sure we keep our hair cells that are inside of that shell-like structure in the inner ear as healthy as possible. All right, some signs of hearing loss. Typically, if a person is experiencing hearing loss, it sneaks up on them, okay? It's gradual, and typically they will notice it in having a lack of ability to hear human speech. Typically, if a person is more soft spoken, if a person has hearing loss, they may have trouble hearing that person speak. All right, a little bit more about those types of hearing loss. So there is the temporary type of hearing loss, also known as conductive hearing loss, that is treatable. And so if you're treated, or if it's something like an ear infection that's causing it, for example, and that ear infection clears, your hearing can go back to normal. Versus permanent hearing loss, that happens when those cilia or hair cells in the cochlea, that shell structure in the ear, get damaged and die. And what causes that type of damage is repeated exposure to loud noise. Okay, that type of hearing loss is permanent. It's irreversible. And then there's acoustical trauma. That is trauma, that could happen by an event like an explosion, or using, certain types of firearms that are extremely loud. And that type of exposure could cause either long-term or short-term hearing loss. It just depends. All right, here are some examples of the noise levels that we have found in some of the shops that you might work in. And as you can see, they have the potential to be well above 85 decibels, okay? And in some cases, much louder. All right, so one of the main ways that we minimize exposure is through wearing hearing protection, true hearing protection, not things like cotton or tissue stuffed in our ears, okay? So hearing protectors are devices that are designed to filter noise, to prevent that noise from getting to the inner ear, where those nerve cells are, okay? And so there are three broad categories of hearing protection. There are earplugs, ear muffs, and then there's this third category called ear or canal caps. In general, ear or canal caps are less protective than earplugs and ear muffs. So we only recommend that you wear earplugs or ear muffs, okay? A little bit more about earplugs. They come in different shapes and sizes. In general, they are typically either made out of foam or plastic, and it's important to have access to more than one type of earplug so that you can make sure that you are using the one that fits properly inside of your ear, because how well it fits inside of your ear is what's going to get that seal in your ear canal and prevent the sound from getting through into your inner ear, where those cells are, those hair cells are, those nerve cells. All right. It's also important that the earplug is comfortable to you, because if it's not, you're not going to want to wear it for extended periods of time. There is a proper way to insert an earplug depending on the type of earplug that you have available to you. There are types that require you to roll them down before you put them in your ear and to pull your ear up and out and to insert them, versus types where you don't have to roll them down, you just have to push them in. It just depends on the type, and the instructions on how to put them on are typically on the packaging. You need to follow those instructions very closely. again, because how well you put them in your ear and they fit you will directly relate to how much noise gets filtered out. Similarly, with ear muffs, you want to make sure that if you're wearing an ear muff, it lays flat around the perimeter of your ear and has complete contact with the side of your head so that it can filter out noise properly. All right. These also require maintenance, so you have to keep them clean and you have to inspect them to make sure they're not cracked and they're still in good condition. All right. Again, ear caps, though it's hearing protection, not protective enough for the type of exposure that you're going to have in grounds and in the carpenter shop and in the mason shop, and some of the other locations across campus. Okay. Now, every type of hearing protector has what's called a noise reduction rating, also known as the NRR, and all that is a decibel level that will tell you how much noise that device will filter out if you wear it properly. It's a target number, and how close you get to it is directly related to how well the device fits you in or around your ear. All right, some things to consider. Earplugs that are not well inserted into the ear canal will not provide complete protection. We talked about why. Same thing with ear muffs that are not snug against your head will leak noise into the ear. Also, hearing aids are not hearing protection, and headphones and earbuds used strictly to listen to music are not hearing protection and only add to the background of other noise. Other things to consider. Disposable earplugs should be discarded at the end of each work shift at a minimum. If they're dirty, they should not be reinserted in the ear. You just want to throw them away and get another pair. If you're wearing earmuffs, you want to keep them clean. And if they are damaged or malfunctioning, you want to dispose of them. Okay. All right, we're in the home stretch. Just a couple more slides. Let's talk about audiometric testing, also known as hearing tests. I mentioned in the beginning of the presentation that you're going to need to get one, and that's being scheduled for you if you haven't already had it within the next week or so. This is considered your baseline hearing test, and you're also going to get one at the end of the summer. And the reason why these are done is to first see what your hearing level is at the start of your time here. And then when you leave, we just want to confirm that it hasn't changed and that no damage has occurred. Okay. All right. So that is done up at the McQuaid Health Center by a trained and certified technician. And what they're looking for is at the end of this is whether or not you've experienced any hearing loss. And the hope is that you haven't. But if you have, then we want to make sure that it gets treated properly. All right. A little bit more about how EH&S measures your noise exposure. We use these instruments to do that. We use a handheld sound level meter that tells us what the decibel level of noise is that's produced in certain environments or by certain equipment. And then we also use a mini version of that sound level meter called a dosimeter, where we would have a worker wear that on their collar for an entire workday. And that tells us how much noise they were exposed to, averaged over 8 hours. And that's how we know whether or not their exposure is above what OSHA says is safe. Okay. And lastly, these are the things that you can do to minimize your exposure. Wear your hearing protection properly. Try to limit how much time you spend in high noise areas or operating noisy equipment. And then the leadership in your shop should continue to look at ways to minimize noise exposure by enclosing equipment, perhaps, that produces noise, or purchasing equipment that is quieter. All right. Okay. Any questions about any of that?